Hello! Let's walk through the course curriculum so you have an idea of what to expect in this course. Now, some of these topics may seem intimidating at first, but they are all connected and they are all key components that make you a top-level developer. We're going to go step by step, working on real problems, writing code, practicing, so that we can feel confident with each one of these topics. Now, the first part of the course is going to cover SSH. And in this SSH section, we're going to learn about the SSH command, how to access remote computers, how to connect to a server that is in another part of the world. We're going to learn about encryption, about symmetrical and asymmetrical encryption, as well as hashing. And we're also going to learn about SSH keys, about generating SSH keys, what public and private keys are, and how to manage them on the server. We're going to have some fun exercises where your app was just deleted off of a server in the middle of the night, and you have to move all your project files back onto the server using SSH. And we're also going to set up GitHub with SSH. After a nice section to start us off, we're then going to dive into a big topic of performance optimization. And this is so big that I've divided this into 3 parts. The first will be network optimizations. We're going to talk about how we can minimize our files and improve delivery of our application. And then we're going to learn about front-end optimizations, about the critical render path, how to improve it so our website can load fast. We're going to learn about progressive web apps and about optimizing code. And we're going to help Keiko Corp actually improve their company website as well as their RoboFriends app. We're going to make a progressive web app that works offline and can even be submitted to the App Store using just JavaScript, HTML, and CSS. But we're also going to learn about interesting topics like code splitting and making React and Redux applications fast through smart rendering. We'll then finish our complete understanding of performance optimizations by working on the backend optimizations, talking about content delivery networks, scaling databases, compressing our responses, caching, and finally load balancing, where we'll implement a load balancer and actually do some load testing on our project. By the end of it, you're going to be a performance guru. We are then going to get into React and Redux, the most popular front-end libraries to build single-page applications. We'll first have a nice introduction to React if this is your first time learning it. And then we're going to quickly dive to Redux, talking about state management and how to structure your apps so that they can grow. And we also add a nice small section on bundling, on using the latest Webpack, as well as an up-and-comer like Parcel to bundle our files and make our production bundle optimized. By the end of it, you're going to feel comfortable with React, Redux, as well as setting up your projects with things like Webpack. We then get into a topic that is so important, but also often forgotten when you're first starting out: testing. Companies love testing. And if you know how to test, how to write unit tests, integration tests, you write better software. We're going to start off by learning about the test landscape in the current web developer world, what tools to use, what libraries there are, how to set everything up. And then we're going to work with Jest, one of the top libraries to use for testing. Write synchronous as well as asynchronous tests, write mocks, and have coverage reports. We're then going to dive into writing tests for our React app and making sure that we use things like snapshot testing and Enzyme to write smart tests that avoid bugs in our applications. By the end of it, you're going to know the entire testing landscape and feel comfortable writing any tests that come your way. We then dive into one of the hottest topics coming out of last year's web developer environment: TypeScript. We're going to learn about static typing and why JavaScript didn't have static typing and instead is dynamically typed. And then we're going to learn how to use TypeScript, what types there are, and how to add them to your project. We're then going to finally add TypeScript into our React project and see how to add it to your own projects. By the end, once again, you'll master this topic. From there, we dive into a short section on single-page applications. We're going to talk about server-side rendering, the original way to display websites, why it was useful and why it still may be useful, and some companies still need it. We're then going to talk about single-page applications and client-side rendering. Again, the benefits and pros when you want to implement one over the other. I'm going to show how to implement server-side rendering in React, and again, what the pros and cons are of each one. We're then going to dive in quickly into Next.js, a library that allows us to write server-side dynamic applications very nicely. By the end, you'll be ready to make decisions on whether you want a single-page app or a server-side rendered application for your project. From there, we dive into one of my favorite topics, security. We're going to cover a diverse range of topics, including front-end security, where we talk about cross-site scripting, injection attacks like SQL injections, and we'll actually practice those to see how they work. We're going to talk about back-end security and what the best practices are in order for us to manage sensitive data. From there, we learn also a few ethical hacking techniques so that we can protect ourselves when we're building our app, so that you feel confident by the end that you are building secure applications using the latest tips and tricks. And then we get into Docker, a tool that's going to absolutely amaze you. We're going to learn about containers and how containers have now revolutionized how companies structure their applications. We're actually going to write Docker files and create our own containers. And then we're going to use Docker Compose to compose a Redis server, a Postgres database, and an API server all into one so that they all run from one command. By the end of it, we're going to feel very comfortable with Docker whenever we deploy our applications. We then start learning about a new database. Redis is one of the most popular and often used databases that is a key value storage. We'll first dive into the topic of databases and the type of databases that we have. From there, we'll spin up our own Redis server, learn how to use Redis, how to use the Redis CLI, so that we're able to use Redis now for caching to make our websites faster, as well as for session management, something that we'll cover in the next topic. Using our SmartBrain app, we're going to create an entire dynamic part of the website that is user management. We're going to start off by creating a new profile page. And using this profile page, we're going to learn about session-based authentication, where cookies would be used, and also about token authentication, such as using JWT tokens. We're going to learn about each one of those, what the pros and cons are of each, and then we're actually going to implement a secure authentication flow that you can implement in any app that you choose. We're going to use Redis for session management so that we have protected routes, and this way, anytime we have a sign-in functionality or we have members, we can use this system knowing that it's secure and it follows best practices. Yes, we still have more topics. This course is quite extensive. We then are going to talk about AWS, what Amazon Web Services is, and also what infrastructure as a service and platform as a service has done in terms of allowing companies to really scale or work as efficiently as Google or Amazon or Microsoft. And then we're going to learn about this exciting serverless technology called Aws Lambda, which allows us to run just simple functions in the cloud. And we're going to use the serverless framework to actually implement Aws Lambda into our SmartBrain application. By the end of it, you're going to feel confident working with AWS and creating functions that live in the cloud. After we've tied everything together and created the overall picture of how to write good software, good applications, we're then going to talk about how to actually create good processes, how to actually deploy to production. We're going to talk about good continuous integration practices, then also about continuous delivery and continuous deployment, so that when you are put on a project, you know how to implement good practices and good tools like Circle CI to make sure sure from the start your developer team has the right tools and the right processes in place to be successful, to write applications with less bugs and cleaner code. And then a little extra bits area where I talk about some of my personal experiences and opinion. I talk about code analysis and what to do when you first start off on a project where you have a ton of files and you didn't write the code yourself. We're going to talk about tips and tricks to really optimize that. I'm going to talk a bit about best practices that we couldn't include in the other sections, and then a couple other little extra bits, so that by the end of it, by the end of the entire course, all of these things will make sense to you. You'll be able to implement all of these things into your own projects, into your own company, and you'll know how each and every one of them are connected. But most of all, by the end of it, you're going to learn things that took me years and years to learn. In the next video, your first day of work is finally going to start at Keiko Corp. Enjoy the projects, enjoy the exercises. We're going to be building a lot of fun things. Have fun and enjoy the ride. Good morning. This is you. You're starting a new job today. You're excited but nervous. This is a big shot company in Sun Valley. Its name is Keiko Corp. It's the biggest company that everyone is talking about, and it has two big products that has made it famous. One is a RoboFriends app. Everyone is collecting these robots, and it's hotter than Pokemon Go. The other is a face detection, smart brain app that is going to revolutionize the whole industry. This is a big opportunity for you. Let's get to work. You get into work. You meet the team and the boss. His name is Bruno, by the way. He always has perfect hair. I don't know how he does it. Anyway, after a few minutes, he pulls you to the side and tells you, "Senior developer just left the company today. I hope you can fill the big void that he's leaving behind. No pressure," Bruno says. But wait, you're terrified. You're not a senior developer. Anxiety rushes over you. He wants a lot of things done. A little bit later, you find out that the senior developer just left to go work for Google. Great. Those are going to be some big shoes to fill. But back to Bruno. Bruno says that there's quite a few things he would like to do with the company. And he wants your help. And as a matter of fact, you look confident and smart. And he wants you to take the lead on their projects. There's a pile of tasks that he would like you to complete to really make Keiko Corp the best software development company. So let the adventure begin. Okay, back to me. The story may seem silly, but this course is designed to mimic real-life scenarios. In each section, you're going to learn something new that is considered a hard topic for a junior developer. But you're going to master it. Then we're going to implement whatever we've learned for Keiko Corp's projects so that you can be a superstar developer you've all wanted. This course is designed to have everything flow together and each topic build on top of one another, like Lego blocks. To get the full experience, go through each video in order. And once you are done the course, you can use the videos as reference to each section you want to go back to. By the way, creating a course suitable for everybody is difficult. The course starts off fairly easily, but we'll get into harder and harder topics as we progress. What I can promise you is this, that topic is relevant to no matter what level of your experience. So stick with it, and good luck in your journey. Hello, and welcome to the very first part of the course. We're going to be covering quite a lot of topics that span from front end to back end. But by the end of this course, you should be comfortable using all these tools and technologies. Although these topics may seem quite different from one another, the course was designed in a way to have everything flow together. Although you can skip sections, I recommend you do them in order because I show you how to connect the dots on all of these technologies and what you can do to build great professional software. And the software that can compete with some of the biggest tech firms. So hold on tight because we're going for a ride. The very first topic we're going to cover is the exciting topic of SSH. SSH, or Secure Shell, is a protocol. What does that mean? You may have heard of other protocols like HTTP, HTTPS, FTP. These are all ways to connect two computers and have a shared agreement of how to communicate. It is their protocol, or language, that they can speak, and SSH is a way for machines to communicate with one another. For example, HTTP, or Hypertext Transfer Protocol, allows you to send files over the internet like HTML, CSS, and JavaScript files between browsers and servers. FTP, or File Transfer Protocol, allows you to send files as well and is often used when you upload files to something like HostGator or a generic hosting platform from your computer. HTTPS is similar to HTTP, but it is encrypted. That means third parties can't read the files being transferred if they intercept messages. And there are many other protocols like IMAP that allow users to send emails and tons of others. And just like these, SSH is another protocol that allows us to communicate between two computers over the internet. It allows users to share files as well as control and modify remote computers over the internet. Sounds pretty cool, right? It was created as a secure way of communication, which again encrypts all data so bad actors can't monitor you. And don't worry, I'll go deeper into each one of these points later on in the videos. Now you might be thinking, okay, so what's the difference exactly from HTTPS? I mean, they're both a form of communication and they're both encrypted. Well, just like a browser uses the HTTPS protocol to talk with servers and display websites, a shell needs a certain protocol to enable data exchange or communication between two devices and not just a browser and a server. And that SSH is called Secure Shell Protocol. It's a protocol to use over shell. And if you remember, a shell, unlike a browser, allows you to talk to the operating system. Yes, you've used your command line before, right? With SSH, I can use my terminal right over here, which represents my computer, to talk to another computer. Let's say this was another computer somewhere in the world. Well, I can now communicate using SSH from my computer to this computer over here through our terminal. Now, the significant advantage offered by SSH over predecessors is the use of encryption to ensure secure transfer of information between host and the client. The host refers to the remote server you're trying to access, while the client is the computer you're using to access the host. And as you can see, that bad guy up there that looks very suspicious, he can't read our messages because of encryption. Now in the next video, I'm going to show you how to use SSH and finally talk about why this is useful for a web developer. Trust me, it's going to be fun. See you in the next one. Bye-bye. Welcome back. Now, let's talk a little bit about state of front-end development. I'm sure you'll have this question. And you've definitely seen these three logos before: Angular, React, and Vue.js. These are the top three frameworks and libraries to build your front-end applications today. All of them with the goal of managing large applications on the front end that have a lot of JavaScript. You see the files over here. They need to manage that. And they were built to solve that problem. For companies to be able to hire developers and make sure that these developers can work with many lines of code in a nice, clean way. Now, there are plenty of articles out there comparing these tools, so you can read that on your own. Because if there's one thing certain in the JavaScript community is that there is no shortage of these articles. However, I do want to add one thing that a senior developer knows. These libraries and frameworks are just tools. And just like tools, each one of them is perfect for its own specific use case. Now, you'll always find people that say, oh, this library is the best, the other one sucks, I'm Team Angular, I'm Team React, or that they'll never ever build an app using this other library. This is not a good way of thinking and doing things, especially when it comes to these three front-end tools. You see, each one of them has pros and cons, and a senior developer only cares about which tool is good for the job at hand. And I want you to start thinking like this and avoid following a library like the answer to all the problems in the world. That simply won't ever exist. There's never a tool that solves everything. Tools change, libraries evolve. And you may be a Vue.js expert now, but in 5 years, if things change and there is a different tool that's even better, you need to be able to adapt. So think of these as tools, each one with its pros and cons. And as a senior developer, you'll be able to look at them and say, this is good for this problem, this for the other, and be able to pick tools accordingly. Currently, though, if I was going to pick one of these, this is what I would do, and this is my thinking process. If I was working for a large bank with massive code base, I'd pick Angular. Why? Because Angular is a framework, which means it is an entire kitchen that they offer you, and its own way of doing things. It is opinionated in that it has specific ways of doing things, so that if you have a lot of developers, like a bank with a massive project, you can be sure that everyone sticks to the rules. Everybody's working in the same kitchen with the same tools. I would pick React if I work for a company with a strong developer team, and that also needs to be flexible and evolve by adding different libraries and tools to the ecosystem. And I can trust developers to build on top of React with all these different tools, something that works for our company, something flexible. I would pick Vue if we want a simple way of writing code that is friendly and might be easier to pick up if you hire a lot of developers. Now, these are just my opinions. I want to start thinking this way. Think in terms of pros and cons, like I said, and not absolutes where we say, this is the best, this sucks. Senior developers don't do that. For now, though, you should know that React is a clear winner. You can see this graph over here. I know there's tons of graphs out there, but React stands above others. And this might change over time, but again, it's good to not really excited about Vue.js because it's become really popular with maybe wait until it picks up and jump. But again, there's something to look at. The reason I teach React in this course is the biggest job market in Vue. I mean, that too, definitely part of the consideration. It's mainly because it teaches you really good tools that will last you life beyond just the library. With Angular, for example, hard to do. Let's go back to again. A good way of thinking about these is Angular, like an entire kitchen with all the tools you need to cook what you want. And everybody works in the same kitchen. React is the want to cook something, yeah, we'll use the oven, but we also need a tool. Use whichever tool that we want and add it to be able to build it. But it allows build. And think of Vue as the microwave. Super simple, easy to pick up, and a lot less complicated than an oven. So, need to make sure everyone uses the same kitchen to cook? Use Angular. Need to get a little flexible and creative, maybe have some creative freedom? Use one and so forth. I know it might be a silly example. It's good. For now, we're going to be React. All right, time to get started. I'll see you in the next video. Bye-bye. Hey everyone, there's a new update with React. And up until now, we allowed to do code splitting with React. And let's be honest here, it was kind of hard. It was kind of cumbersome. Well, with the newest version of React, we now have something called React Lazy. And React Lazy, it allows us to do code splitting very, very easily. So in the previous exercise, I asked you to try and implement this yourself. If you're able to get it, good job. Otherwise, let's see how we can incorporate React Lazy to do code splitting. Let's get started. So we have our repository that I gave to you. And all we have to do here is just simply clone this repository in our terminal. So let's say git clone. And we'll into this repository. Now, the very first step we're going to do is say Apm Install. And oh boy, that's not good. We've seen this before, right? In the React section when we talked about updating packages. If we don't maintain our packages and keep them up to date, well, usually without updating our packages, we'll probably have some vulnerabilities. In this case, oh boy, there's 2 critical vulnerabilities, 655 high ones. That's not good. So let's fix that. And we've already done this before. So all we have to do is say npm audit fix. So we'll fix them up. That feels good. We fixed a bunch of things, but you hear that we didn't fix all of them. Some of them, 27, require manual review. Again, something that we've already talked about in the React section when we talked about updating packages. Although I recommend actually going through the packages and making sure that we want to update them, because it is a simple project, we won't have any breaking changes. We can just run npm audit fix -- force to make sure we fix all the remaining vulnerabilities. Also, I don't know if you can hear this, but there's a massive rainstorm happening outside. So if you hear water trickling down, I promise you I'm not in the bathroom recording this. All right, things are looking good. It looks like we had 1 package that involved breaking changes and 3 vulnerabilities requiring manual review and could not be updated. But we'll get back to those in a second, because now we should be able to do npm start and see our project run. But before we do that, let's open up the code into our favorite code editor. That's great. And then let's do npm start. Everything should be working. There we go. Our nice, beautiful page. Now, if you clone the repo like I just did, and we open up the console here, or the network tab, let's make sure we clear everything. When I click on page 2, well, nothing happens because we're not doing any code splitting right now. The way this file is set up, if we go into app.js, is that it has the 3 things that we've done. The no code splitting part 1, which is what we're doing right now. have the part 2 code splitting, which we've talked about before, right here. And then we have part 3, which was the code splitting using the async component. So if we comment these out and do part 3 async component, scroll all the way to the bottom here, comment out the render with the no code splitting, and comment the part 3 with the async component. If we save this, go back and refresh, let's clear this. If I click on page 2, there are chunk 2 and chunk 3 are loading because now we're doing code splitting. But we have a better way, right? We have a React Lazy that allows us to do code splitting. So let's see how that would look like. First, we see that now we can use something called React.lazy when we import the components. So let's do that. Up at the top, we'll comment the async component out and do part 4. Let's make this a little bit bigger. And part 4, we'll use React.lazy. Now, React.lazy can be used like this. We can say const, let's call it page2 is going to equal React.lazy. And then from here, if we look at the documentation, we simply have a function inside here. So if we copy this, we have a function that dynamically imports a component. In our case, we want to import the page 2 component. So let's add this here and then do the same thing for page 3. So again, we'll say page 3 lazy and we'll import page 3. There we go. So now we have this lazy component, which tells us, hey, only load up this component, be lazy, and only load it up when we use it in the render function. So now, if we scroll all the way down, instead of part 3 here where we use the async component, we're going to do part 4 using React.lazy. And we're going to copy this and show you the difference. So if I copy and paste, there we go. We don't need an old async component way of doing things. Now in here, we no longer need to use this async component. So let's just remove this line because we're importing up at the top here. We also don't need this line either. There we go. And now, instead of async page 2, we use the page lazy component. And then same here, page 3 lazy component. Just like that. Now, the last thing we need to add is, we look at the documentation. What React Lazy does is it's a function that lets us render a dynamic import, right? But that means if we're rendering something dynamically, that is when React sees in the render function that, oh, we need page 2, it's going to import it. But while it's importing it, the user is going to be staring at a page thinking, what's happening? Where is the component on the page? So the lazy component should be rendered inside what we call a suspense component, which allows us to show some fallback content, such as a loading indicator, while we wait for this component to load. Because again, it's going to look at this component and it's going to say, oh, we need this component. Let me go import it. And while that importing is happening, even though it's super, super fast, we want to have a fallback. So the way we do this is that we always wrap these lazy components in a suspense component. And again, this is a new feature of React. So all we have to do is wrap this in a suspense component. And this suspense component, if we look over here, has to have a fallback attribute. And this fallback attribute, or property, needs to have or return a React component. So in this case, we can do div loading, but we can render anything we want. So this is the fallback. It says, hey, while page 2 is loading, or if something happens and we can load page 2, well, in that case, the fallback should be this component. And this suspense is a new feature. That means we can import this component because it comes with React. So in here, I can just say suspense, just like that. So now that we've imported suspense, we can include it in here and wrap all our lazy components. So once again, we do the same thing here too. We say return. Let's copy this. We'll have a loading component again with a suspense fallback, just like that. We close suspense. Now, if I save this, let's make sure we shut off the brackets. So we're returning a component, a lazy component wrapped in suspense. So if I save this, looks like I don't get any errors. That's good. But what happens when I try to run this? Let's go back to our app and refresh, and Webpack default a lazy is not a function. So React.lazy is not working. You think why that is? Well, remember what I said. React lazy and the suspense component is actually a new feature of React. And if you look at our package.json, when I originally recorded the videos, the latest was 16.2 React. But if we look at the React version, well, that's definitely higher, isn't it? So what we need to do is update this React package so that we can use the latest feature, that is React lazy and suspense. Now, there's a nifty little way for us to do that. And that is when we close the server, we can just do npm update, which will update the packages because we have these carets. It's going to say, hey, update the package to any minor version update that you have. So if I do npm update, there you go. We've updated our packages. And when I click on package.json, notice how the version number changes. Hey, that's nice. That's better. So now we have the latest version of React. So if I do npm start now, we should have React lazy and suspense component available to us. And one thing I realize here is that suspense is spelled with an S here. So make sure you're careful here. It's suspense, not with a C. So make sure that we have suspense spelled properly. So we have suspense, 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 suspense. Because the compiler actually won't give you an error. Instead, you'll get some key errors and you're going to be wondering what's going on. So that's actually a common mistake, especially non-native speakers. So let's save. We get no errors. Package.json, everything's updated. So if we go back to our app, okay, we have page 1. Open up Developer Tools. No errors. If we go to the Network tab, let's make this a little bit bigger. Let's clear everything. If I go on page 2, hey, look at that. I got my first chunk, then page 3, the second chunk, and no errors were found. Just like that, we've used React.lazy to lazy load components only when we need them. And this is, I would say, quite an improvement, right, from what we had before. Again, one of the beauties of having React constantly updated is that when common problems occur, we try to find the easiest solutions and hopefully add these new features to the library so that we make our apps more performant and also simpler to build. And now we have an updated app with all the vulnerabilities gone and code splitting in effect. I'll see you in the next one. Welcome back. Now, one thing you may have noticed, if you're really paying attention, is that these tests are fine for now because the Swappy API is fairly fast and we're getting the data back fairly soon. But imagine if we had many of these tests. Imagine if we had APIs that return a lot of data that takes a long time to actually get to. You can imagine this growing bigger and bigger until it takes forever for our test to run. I mean, it only took 2.557 seconds, but with more and more tests, with more and more asynchronous tests that we wait to actually get a data response, it's going to take longer and longer. And if we're developers and working and saving our work constantly, if we have to wait a couple of minutes for us every time, that's really going to slow us down. How can we improve this so that we're always doing this fetch call? Well, we can use something called mocks. With a mock, we can fake a function and just pretend to have it running, so that we can use this mock to let us spy on the behavior of a function that is called indirectly by some other code, rather than just testing the output and waiting for the asynchronous code to complete. And you can create mocks in Jest really, really easily. So let's do that. Let's create a mock here to speed up our asynchronous tests. The first thing we're going to do, let's create more space here. I'm going to, again, create a new test. We'll just call this get people returns count and results. And in here, we'll do the same thing. Second parameter is a function. Now, we're going to create something interesting. We're going to mock this fetch because, first of all, Node fetch is a third library, and if we've really tested out the library code and we checked the GitHub repo and they have tests, we don't need to test that it works. We can assume that the fetch function works as intended. So let's do a mock fetch and mock fetch, and this is going to be a variable. So let's just say const. We can mock the fetch, and we can do that in Jest. Again, if you remember, this is something that comes with Jest, mock, spies, and stubs. Otherwise, if you're using something like Mocha, you'd use sign-on. But we can just do jest dot fn function. And we can do something called, again, this is all in their documentation. We can do something called mock return value. And we can just return something as if this fetch function was called. So what does a fetch function usually return? Well, we know that it returns a promise. And let's just for now say that it's always going to resolve. So that is a resolved promise. And inside of this resolve, let me make this a new line just so we can see it better. That's better. In here, man, let's make this a little bit smaller. We want to resolve to an object that is JSON. Because if you remember, we always have to do the .then response.json. So we can just mock this whole thing out. We can say that JSON, so the object that we return, is going to be a promise. So we're going to resolve a promise with the JSON method. And this method, again, is a promise. So again, promise.resolve. And the promise, again, with this part, we're doing this, the .json. And then we get the data. So we can say that within the resolve, we'll have count equals 87. And the results will be, let's just create an array that says 0, 1, 2, 3, 4, 5. Let's save this and get a bit of a syntax error. Let's fix that. We have an unexpected token, and I forgot a comma over here. Classic commas, they always get me. All right, we just mocked the fetch call. Instead of calling this get people promise and wait for the data and get the data.count, data.results, we're actually just doing that automatically, assuming that the API works. So we can just test our other parts of the function. Again, because this is still synchronous, we're returning a promise, remember. We'll want to do a return swappy.get people. Now let's get people promise. And in here, we can, instead of the fetch, do the mock fetch. We're mocking the function that is fetch. And this is how we test. We can use dependency injection to make sure that we're testing different functionality. And you might remember this from integration tests. But without actually using up all these resources, we're trying to be as smart as possible. Now we can have the .then, and we're going to receive the data, just like we did up above over here. Now within here, let's do a few tests. We want to expect the mock fetch. That's right. Because we use jest.fn, we now have an ability to listen in, because in jest, this is also a spy. We can spy on this and see what this function did inside of this function. So what did mock fetch do? And get people promise. I can say expect mock fetch dot mock. Again, this is in the jest documentation to have a calls. So how many times has this been called? I'm going to say length. So the number of times it's been called to be 1. Let's save. And this is passed. But remember, with asynchronous tests, we want to always do the expect dot assertions to make sure that they're being called. So in this case, we only have 1. Everything works. If I change to 0, that fails because we actually did call the mock fetch. This function called the mock fetch once. Very cool. What else can we do? Well, another thing we can do, and let me just copy this. We can expect mock fetch, have another method called to be called with. And we can test to see what this was called with. In our case, it should be called with this URL. So again, let's put it in here. Let's test this. I'm going to save. Oh, and actually did make a mistake. We want to do expect, again, the fetch to have been called with the URL. Let's save. Oh, and remove the bracket. It's actually passing, but remember, our assertions is now expecting 2 things. So I'm going to save. Do you see how it took a little bit more time this time? Again, because we're repeatedly calling this API, it's taking a little bit more time, this time 3.981 seconds. But with the mock, because we're doing promise.resolve right away, it's a lot faster. And that's passing. If for some reason I change this to and we expect it to call planets instead, we see that it fails because we expect the get people to actually get the people, not the planets. Very cool. All right, let's do a few more. Well, let's just add, again, copy and pasting in testing is not bad. Let's just copy and paste this and expect that things work the exact same as they did in the above with the regular fetch, but this time with our mock. So we can save, go back, and I have a test failing because now our assertion number is 4. Woohoo! Everything is passing. And if I change this count to 89, and I change this to 89, but let's say greater than 10, it should fail because our results only have 6 items. There you go. But if I change this to greater than 5, our tests are passing. Very, very cool. And there you have it. Other than learning a few methods, such as to be greater than or to equal, which you can always check in the documentation when you test, everything is pretty simple, right? Once you get the hang of it. We have synchronous tests that are very, very easy, and we just have an expect assertion. And then we have asynchronous tests that we just have to remember to return and make sure that we have access to the promise, whatever it returns. And then we can also, to avoid long-running asynchronous code, such as API calls or maybe even a database call, to mock. And mock functions, also known as spies in Jest, because they let you spy on the behavior of the function, is called by our test, and it's going to spy on what is happening. And you know that get people promise actually runs this mock fetch that we created. And all you need is this syntax. And here we just added extra things because we wanted a certain behavior. But even just doing this, we could have seen that mock would have been called with this URL. Jest is an awesome, awesome tool. If you work with other libraries, you'll see a lot of similarities. Like I said, mocks, stubs, and spies can also be seen in sign-on, especially if you work with Mocha. But overall, the principles are the same. And you can see that tests can be fun because we're just testing logic. And nothing feels better than getting all these green passes. All right, that's it for now. I think it's time for us to get into some React testing and testing our RoboFriends app. I'll see you in the next one. Bye-bye. Welcome back. There are a ton of programming languages out there. We've heard of them, right? Python, Ruby, Java, C++. There's a ton. And although JavaScript is the dominant language on the web, and with the introduction of things like Node.js, we now use JavaScript outside of the web, perhaps in the backend server as well. The world still has many different languages that are suited for their own domain and ability. And if we had to categorize all these programming languages somehow, we would probably do something like this. In this video, we're going to talk about the main spectrum here, the dynamic and static of how programming languages can differ. Dynamically typed and statically typed. We see over here that JavaScript is a dynamically typed language, and so are other popular programming languages like PHP, Ruby, Python, Clojure. On the other hand, languages like Java, Haskell, Scala, C++ are static or statically typed languages. But what does that mean? Well, let me actually just demonstrate it for you. If I open up the console here, and oh, that's a nice background today. Anyway, back to the console so we can type some JavaScript. In JavaScript, because it's dynamically typed, we can do something like this. Variable a equals 100. All right, that's pretty expected. We know how JavaScript works, and that's fine. But in some languages, this wouldn't work. You see, a dynamic typed language allows us to not have to say what type of variable this variable a is going to be. What does that mean? Well, in a statically typed language, let's say we were writing C++, which is a statically typed language, we'd have to do something like this. And I won't get highlighting because, well, browser won't recognize C++. But if I was about to do the same thing, I would have to say int a, and int stands for an integer. And then on a new line, I'll say, let me add a semicolon here. And on a new line, say that A equals 100. You see, with a statically typed language, I have to say what kind of type this variable is going to be. In this case, it's an integer. If this was a string, like a hello, I'd have to say string, and so on and so forth. So with a static typed language, we have to declare the variables explicitly before using them. Dynamically typed languages are not bound to this constraint. They're not bound to a particular type. JavaScript is smart enough and it's going to say, oh, yes, variable A, that's 100. Oh yeah, that's an integer. It's an integer. Wow, I'm so smart. That's what JavaScript is saying. And in dynamic typed languages, type checking is done during runtime. What does that mean? Well, if you remember in our discussion about the browser performance, JavaScript gets run on the browser in the runtime or in JIT or just-in-time compilation. While the user is actually browsing through the website, JavaScript is running and being compiled in the background. If you remember our performance tab, we had our scripting performance metric, which was that yellow pie graph, or the piece of the pie graph that was yellow, that included the compile of the JavaScript as well. And because of that, we're able to use dynamically typed languages that can assign anything to any variable, and you're not going to be caught. You might get errors during runtime while the user is browsing your website, but because of this, we're able to just not have to worry about this. Looks pretty nice, right? Why would we ever want to do this? This is just so much cleaner and easier for us to write. Well, we're going to see why that might not always be ideal and why it might cause a problem. But before we get to that, there's been a holy war going on in programming languages. People that think statically typed languages are the way to go and think dynamically typed languages are horrible, and vice versa. People that say, oh, statically typed languages are a waste of time and dynamic programming languages are the way to go. Because of that, I'm treading lightly on this topic because people are so opinionated. They have such strong opinions about this. But again, as senior developers, let's not focus on what is right, what is wrong. Let's focus on pros and cons, when one is good over the other, so that we can make smart decisions. Let's talk about the pros. The number one thing with a statically typed language like this is that we get documentation. Perhaps a better way to demonstrate this is to actually write a function. If, let's say, I was going to delete this and say function sum, and in this sum here, I'm going to use a bit of a syntax that might not be familiar to you, but for now, it's fine. We'll just assume that this works. We'll say A is a number, and B is also a number. And in here, you can just return A plus B, close our function bracket. This is in JavaScript. If we ran this, we're going to get an error. But this demonstrates what a statically typed language could. You see, if a new developer came along and ran the sum function with something other than a number, let's say that they ran the sum function with sum hello and maybe something null. Well, this, before we're ever even going to put this code in the browser or in production, is going to error out because it's going to say, you're doing something wrong here. I'm expecting a number and a number here, and you're not giving me any of that. And in that sense, statically typed languages are self-documenting. That is, I can come onto a project and immediately see that even if this was named badly and this was a complicated function, I can see what kind of parameters it expects, and I avoid making that error. The second pro of a static typed language is that because of this, with our IDEs or text editors like Sublime or Visual Code or any of your favorite text editor, this helps with auto-completion in your editors. You can download plugins that say, hey, even before you run this, this should be a number. That's also really nice when you're developing. Finally, the most important thing, and yes, there are many more pros, but we're just focusing on the main ones here. The main thing of statically typed languages is that you're going to get less bugs. You're going to get less bugs in production because this will never make it into production. If this fails at what we call compile time, that is, before we even send it onto a browser, then we catch that early. We catch those bugs early so that in production, most of the time, there's going to be less bugs with a statically language. And don't worry, we're going to talk about compiling and how that works later on. Now, that sounds pretty great. Less bugs, easy documentation, helpful auto-completion in editors. So why don't we just do a statically typed language? Well, there's some cons. Number one is that we obviously just made our code a little bit more harder to read. It's more complex now. We're just adding another layer to our programs. And this takes time to learn. If we have our project and we have new people joining our company, we're going to have to teach them how to write more code and how to write this properly. It's an extra layer of complexity. And that's always a concern with programming, right? Adding an extra layer of complexity, is that really going to benefit the project? Other cons or argument against statically typed languages is that, well, why can't you just write better tests? A topic that we cover in another section. Many people get very, very excited about static typing and forget about writing good tests, good unit tests. Before you have static typing, especially in a language JavaScript, make sure that you have good unit tests and you don't forget about writing unit tests and assume, oh yeah, just because I have static typing, I'm not going to get any bugs. That simply isn't true. Finally, with a statically typed language, you're going to have a slower development process because you now have an extra step where while you're coding along, there's also another check to see that you're not making any type errors. And this actually just slows down the development process and how fast you can create code and run code and ship it to production. You see, with dynamically typed languages, and this is why JavaScript was so popular, is that you spend less time debugging syntax and semantic errors like this, and instead, most of your debugging time is spent purely on logic and errors, which, as a developer, are a lot more interesting. All right, let's go back to this. There are a few other pros and cons, and everybody always has opinions when it comes to these two topics. The main point is this. Static types usually prevent bugs and help keep errors from happening. Dynamic typing allows you to be more flexible and write software faster. Typescript allows us to make JavaScript to behave like a statically typed language. It adds types to JavaScript. So JavaScript extra safe. But before I go on and show you a demonstration of how TypeScript works, let's talk about the other two parts of this graph that often get confused with dynamic and static typing. I'll see you in the next one. Bye-bye. Welcome back. Let's keep going with our star of security and talk about code secrets. And with code secrets, it's quite simple actually. There's two main things we want to focus on: environmental variables and commit history. Let's take a look at both. I have over here our RoboFriends, nothing too crazy, same old, same old. There are many times in our apps where we have important information that we might want to hide. For example, sometimes we have an API key, like we do in the SmartBrain app with the Clarify API. That API key allows us to send an HTTP request to clarify for them to respond to us. There's also times where we might want to connect to a database and we need a password and user, and perhaps there are other secrets that we want to have. Or maybe even simply, we just need to have extra variables, what we call environmental variables, in our development purposes. Let me show you how this would work in RoboFriends. For example, out of the box with Create React App, we have access to, let's console log this, process.env.node and variable. And this is saying, in this process that we're running, give me the environment variable node.env. And where did this come from? This is just default that's set by Create React. If I save this and go back and let's take a look at our console, we have our logger, but we see that we have our log over here, development. And this is done by default because internally, Create React App gives us the node.env version. And when we run this, it says, we're running in development. Let's set up the app so that it's better for development purposes. When we actually run npm run build, it'll change this node environment to production so that it's able to say, okay, this is for production, not for development. I'm going to minify the code. I'm going to do all these optimizations, use libraries that are optimized for productions, and do all these things. So environment variables are useful. For example, I could say that if node environment was production, I want to add Google Analytics. For example, I could say if process node.env equals production, then in this block, we can say run Google Analytics or anything we want. And you'll see that a lot. But let's get back to security here. We now have a way to inject variables into this app from the outside world, from the environment. And by doing that, we can inject passwords, database passwords, usernames, and API keys, or even variables that we might need from the environment for our app to work. And the way we can do this with Create React App, and don't worry, I'll show you how to do it outside Create React App as well, is to create a .env file. Oops. So we do .env. And I've actually already created one over here. And in this .env file, I can add anything that I want. With one condition, we have to add the React app prefix. And after this, I can say whatever I want. So let's say hi equals to hi. No quotes here, just the way it is. Save it like that. And now let's copy this. And now console log the process.env, React app, say hi. Except we don't need the equals now because that's the variable. And you might need to reset the server for this to work. So we run npm start again. Let's wait for it to load. And if I scroll up, I might have to save this first. Silly me. Let's rerun npm start again. Yes, use a different port. And look at that. I get hi. So using this, I can securely add passwords to my app. For example, let me show you GitHub. If we go to the SmartBrain project, look at that cat. Let's go to the SmartBrain Boost API. And in here, if I go into controllers, image, you see how I have the API key over here as your API key here? Well, I don't want to commit or show to the public my API key for Clarify because let's say you're paying for that API key. Well, you don't want anybody to have access to it because if they do, then anybody can access and use your Clarify account. In here, I could have done process.env, your API key here, and then every time I download this app, I have my .env file, and that already has my passwords and my keys already set, and I can just run it. And that's how companies usually deploy. They deploy apps by having process.env some sort of a variable key, and each place where they deploy, they have a environment file that is kept completely secret. Remember, most of the time, these are secrets that you don't want the world to know. So sometimes you see .private folder that has all your environment variables for production, staging, local, and different environments. The idea is to keep these as secret as possible. Now, this .env that comes with Create React App is actually a package on NPM that anybody can use. And underneath the hood, this .env package is used by Create React App. But if you're not running Create React App, you can just simply use it by Npm installing. And they have fairly good documentation. You can see over here for DB user, password, and host. I can use this. And now I can use process.env.db password, user, host. And this is the recommended way of making sure that your app runs and knows secrets that shouldn't be shared with anybody in a secure fashion. Now, those are environment variables. And I want to show you something interesting. And this is something that you should be careful of. GitHub has a commit history. When you delete your commits or anything, you're always going to have this commit history. So you never, ever, ever want to put up your secret files onto GitHub because those are public. So always use a .git ignore file or never, ever, ever, ever do any passwords or API keys in commit history. Let me demonstrate why. If you go to GitHub at the search over here, and again, be responsible with this knowledge. Don't use it for nefarious reasons, bad reasons. But if I type in remove, let's try that again, remove password, press enter, and I go to commits. Oh, and this is under my search, but let's go back to outside of this repository to the main GitHub site and try that again. Remove password. And I go to commits. I have 38 million commits that have, let's go to commits here. 389,000 commits that have removed password words in them. So we now see where people have removed their database password. And this is for everybody to see. That's not very good, is it? Again, use this responsibly. This is just a demonstration to show you do not ever commit anything to GitHub that is secret. And if you do, by mistake, since this commit result is going to be there, you're going to have to change your passwords, secrets, whatever they are, immediately. There you have it. Code secrets. Be careful with them, hide them, protect them.